Hello students. Let's dive into a more detailed explanation of oxidation and reduction, along with an example. Oxidation. Oxidation is the process in which a species loses electrons, resulting in an increase in its oxidation state or a decrease in its negativity. It involves the transfer of electrons from one species to another or from a species to an external entity, such as an oxidizing agent. Example: consider the reaction between magnesium, Mg, and oxygen, O2, to form magnesium oxide, MgO. 2 megagrams plus O2, 2 MgO. In this reaction, magnesium is oxidized. Initially, magnesium has an oxidation state of 0, and in MgO, its oxidation state increases to +2. The magnesium atoms lose 2 electrons each, leading to oxidation. Reduction. Reduction is the process in which a species gains electrons, resulting in a decrease in its oxidation state or an increase in its negativity. It involves the acceptance of electrons from another species or from an external entity, such as a reducing agent. Example: in the reaction between magnesium and oxygen mentioned earlier, oxygen is reduced. Initially, oxygen in O2 has an oxidation state of 0. In MgO, its oxidation state decreases to -2. Oxygen atoms gain 2 electrons each, leading to reduction. Redox reaction. A redox, reduction-oxidation, reaction involves both oxidation and reduction occurring simultaneously. One species undergoes oxidation, while another species undergoes reduction. Example: let's consider the reaction between hydrogen, H2, and chlorine, Cl2, to form hydrogen chloride, HCl. H2 plus Cl2, 2HCl. In this reaction, hydrogen is oxidized, and chlorine is reduced. Hydrogen goes from an oxidation state of 0 to +1 in HCl, losing 1 electron per hydrogen atom. It undergoes oxidation. Chlorine, on the other hand, goes from an oxidation state of 0 to -1 in HCl, gaining 1 electron per chlorine atom. It undergoes reduction. In this example, hydrogen acts as the reducing agent since it causes the reduction of chlorine, and chlorine acts as the oxidizing agent since it causes the oxidation of hydrogen. It's important to note that in a redox reaction, the total number of electrons lost in oxidation must be equal to the total number of electrons gained in reduction to maintain charge neutrality. I hope this detailed explanation, along with the examples, helps you understand oxidation and reduction more thoroughly. Feel free to ask if you have any further questions.